This week, find out what Lambda functions are and when you might want to use them, or why you might see them in code that other people have written. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer at Unidata. On this week's MetPy Monday, I wanted to show you what a Lambda function is. This is something that you may be familiar with from other languages as an anonymous function. And there's something that you may not see all that often, but when you do see them, they can be a little bit confusing. They can also be really useful and make your code a lot more concise and read a lot better depending on what you're trying to do. So before you watch the rest of this video, I'm going to assume that you're familiar with how to declare a function in Python and how that works. So let's do that. I'm going to make a function, and it's going to be called add42. So it's going to take some value x, and it is going to return x plus 42. So if I call that function, add42, with the number 10, I should get 52 back. And I do. So that makes sense. That's sort of a silly function, and it's only one line, but I've got 2 lines of code there. Maybe that feels a little bit heavy. We can shorten that up a little bit with Lambda Functions. So I'm not going to say this is not the primary use, but we could do this by, we'll say add Lambda Function, just to give it a different name. Now we're going to use the keyword lambda. So you see when I type it, it becomes green and bold in the notebook since that's a Python keyword. The next thing we do is provide the name of the input argument. So I'm going to call it A in this case. You could call it whatever you want. And then a colon, just like in our function declaration in the first cell there. And now the statement that I'm going to return. So A plus 42. So you see this single lambda call creates that function, and I'm assigning it to the name add lambda function. So this is one line, it's going to do the exact same thing. So if I call add lambda function with 15, I get 57 back. So that makes sense. It's a little bit more concise, but it's probably not the ideal use case for a lambda function. To show you that you can have lambda functions with more than one argument, we'll create a simple adder. So lambda, and it's going to take 2 arguments, a and b, colon, to say this is what I'm now going to return. This is the expression that's going to be evaluated. And I'm going to return a plus b. You notice I'm not using the return keyword, and lambda functions can only consist of one expression. And the result of that expression is what is returned. So you can't write complicated things in these. That's not at all what they're for. So now if I call my adder with 40 and 2, we get 42, exactly as we expected. Okay, so now let's do something a little bit more interesting. And this is where lambda functions really begin to show their power. So I'm going to create a function. I'm going to call it my exponent. And it is going to take a base and an exponent. It is going to return base raised to the exponent. So if I call my exponent function, let's say with a base of 2 raised to the 8th power, we get 256. That's exactly what we expected. But what if I were going to have some functions where I want to raise things to the 8th power or the 2nd power, the 3rd power, so I want to square and cube things? Well, I could write def square of number, def cube of number. But we can use lambda functions and create a function who returns a function to do this. You could think of this as sort of a function generator. This is a little bit silly for just taking something to a given power, but you'll see that it really enables you to write concise bits of code that reuse a lot of power and create all these nice custom functions. So the first thing we'll do is I'm going to create my custom exponent function, and I am just going to take a power here. I'm going to return a lambda. So stick with me and we'll go over how this works, which takes a base and it returns the base raised to a power. So this function, custom exponent, takes a single input argument, power. That then will be available as the variable power inside the function. And it's going to return another function that's created by this lambda, who takes an input base and raises it to that variable power. To do this without a lambda function, I would have had to declare two functions and have one call the other. It would have been a lot more confusing to follow. So what happens when I call this custom exponent function? What type of return do you think we'll get? So we should get a function. So let's do that. So if I call custom exponent, and let's say I want 2, so this would be a squaring, you see that I get a function back. I don't get a result, I get a function. So let's save that off. I'm going to say square is custom exponent of 2. Cube is custom exponent 3. So now I've saved those functions that were returned as function names square and cube. So now I can call square of 2 and get 4. I can call cube of 2 and get 8. And notice these, nowhere did I hard code those values. I'm calling my custom exponent function with the power. It's returning to me a function that does what I need it to do. This could be very, very powerful depending on what kind of processing workflow you're setting up for some data, or for reusing more chunks of code in a library that you're making for your research. Lambda functions have the power to give you very clean reading, extensible, and easy to maintain Python code. So I hope that you found this useful. Don't forget to subscribe so you don't miss any more MetPy Mondays, and go back and check out our gallery of past MetPy Mondays for lots more useful information. Thank you for watching, and I'll see you on next week's MetPy Monday.